Next, let's talk about configuring frame relay. So to configure frame relay, first you must enable frame relay encapsulation on your serial interface. Then you need to do the address mapping. So in the lab, you'll try both static and dynamic mapping. Okay, step number 1, configure and enable frame relay encapsulation. Okay, first, you need to go to the interface where it's connected to the frame relay switch. Next, you configure an IP address. Okay, and then say encapsulation frame relay. Okay, optionally, you may want to specify the bandwidth for the serial interface. Okay, then after that, you can do a show interface serial and then the interface number. So serial 000. Then you can verify if the interface has been configured correctly. Okay, now talk about mapping. You can either choose static map or dynamic map. Okay, let's talk about static map first. Okay, to map an IP address with a DNIC number, the command is frame relay map, and then the protocol is IP followed by the IP address and then the DNICI number. Okay, there's an optional command that you can use. It's called broadcast. Okay, this broadcast is used because frame relay is a non-broadcast multi-access network. Okay, meaning it does not support multicast or broadcast packet, which means if this is your router, connect to the frame relay cloud. Okay, if you try to send broadcast or multicast packet out to the frame relay cloud, okay, the frame relay switch will drop your packet. It does not support broadcast or multicast packet. Okay, so your routing packet like OSPF, ERGRP, they all uses multicast address, so they will be dropped. So if you want to send this broadcast or multicast packet out, you use the broadcast command. So broadcast command basically will convert broadcast packet into broadcast and multicast packet into unicast packet. Okay, so instead of using the broadcast or multicast destination IP address, they will then send it directly to the destination routers that is connected to that interface. Okay, so it's then directly using unicast address rather than multicast or broadcast address. Okay. Let's look at one of the examples. So here, okay, R1 is connected to the frame relay switch, and now first you go to the interface and we are using serial 001. Okay, next you configure an IP address, and then you say I want to use frame relay as an encapsulation. Set the bandwidth, and then you do the mapping. Okay, so the map will say frame relay map, the protocol is IP, the IP address, followed by the DNICI number. So this DNICI number, where do you get this number? Normally given by the ISP. So the ISP managing the frame relay cloud will tell you what DNICI number to use to go to this particular IP address. Okay, so once you configure that, to verify your frame relay mapping is correct, just do a show frame relay map. This will show you number 1, the protocol, destination IP address, DNIC number, and it's using static. Okay, frame relay suffered from this problem called the split horizon. Okay, I'm not sure if you still remember split horizon when you learn from CNET. Okay, basically split horizon say that if the router, okay, let's say there's 2 routers going to, okay, this is connected to a particular network. Okay, so when this router advertise this network, okay, when R1 advertise this network to R2, let's say network A, okay, R2 will advertise this network out to other router, okay, let's say R3. Okay, and split horizon said that R2 will not advertise network A back to R1. Okay, split horizon defines that if you receive an advertisement about a network from this interface, from one particular interface, you should not advertise back the same network back from that interface to that router. Okay, this helps to prevent routing loops from happening. Okay, but this creates a problem in frame relay, because if you remember, frame relay this interface is connected to two different routers, because frame relay, one physical interface can connect to multiple destinations because we are using DLCR number. So let's say they are running some routing protocol, and R2 send a routing update to R1, some routing advertisement. So if you have split horizon running, split horizon will say that when R1 receives the routing packet from serial 000, it will not forward out the same routing packet, okay, out of the same interface, which is serial 000. This causes a problem because R3 is also connected to R1, and R1 is supposed to share the routing update sent by R2 to R3. Okay, because split horizon, it prevents R1 to share this routing information he received from R2 to R3. Okay, so this causes a problem in frame relay, the split horizon. So the solution, okay, one of the solution is to create virtual interface instead of physical interface. Okay, this virtual interface is called sub interface. It's basically a logical interface. That means physically the interface does not exist, but it's a logical interface associated with a physical interface. Okay, so this frame relay sub interface can be configured for every PVC identified by the DLCR number coming to a single physical interface. So to the routing protocol like OSPF or RIP, okay, this physical interface is actually subdivided into some sub-interface. So if I receive the routing update from one sub-interface, I still can send the routing update back out through other sub-interface, although physically they all came from the same physical interface. Okay, so sub-interface can be either configured in point-to-point or multi-point. Okay, let's look at the difference between point-to-point and multi-point now. Okay, this is a physical interface, serial 000. Okay, so we can create sub-interface from this physical interface, and sub-interface are defined by the dot. So I can create sub-interface serial 0.1 or serial 0.2 from this physical interface serial 0. Okay, so again, these are logical interface. They do not physically exist on the router. On the router, you can only see S0. But you can create this sub-interface S0.1 and S0.2. Okay, so let's say for S0.1, I decided to create a point-to-point link. So S0.1 is connected to physically to another point. Okay, so this is a point-to-point sub-interface. Or I can create a point-to-multipoint. Okay, let's say for S0.2, I create I connect this sub-interface into, again, a multi-point sub-interface. So this S0.2 connected to multiple destination. Okay, so obviously, if you are doing point-to-point sub-interface, it solves the split horizon problem. Okay, because if I receive an update from this sub-interface, I can send the update out, okay, to other sub-interface. If you are using point-to-multipoint sub-interface, then it doesn't solve the split horizon problem. Okay, because routing update from this interface going here, it will not be forwarded up from the same sub-interface to the other router. Okay, so that's the difference between point-to-point sub-interface and multi-point sub-interfaces. The advantage of having multi-point sub-interfaces, you can save address space because all these sub-interfaces belongs to a single subnet. So you can help to save IP addresses. But it's not really useful to resolve split horizon problem. Okay, so multi-point configuration or multi-point sub-interfaces help to conserve IP addresses, but it does not work well with split horizon. Okay, so if you want to solve the split horizon issue, we use point-to-point sub-interfaces. Okay. So for Cisco, how does Cisco handle split horizon? So split horizon checking is disabled by default for frame relay. Okay, which means when you enable frame relay on the serial interface, they will disable split horizon checking. That means routing packet received from one interface, okay, can be sent out through the same interface that you received from, except for EIGRP. EIGRP Okay, by default it is enable, okay, and you must disable it, okay, by doing a no IP split horizon EIGRP. Okay, let's look at how do we configure sub interfaces. So the command is interface serial, the physical number followed by the sub interface number. Then once you're in the sub interface prompt, you do a frame relay interface DNCI and the DNCI number. Okay, look at some examples. Okay, number one, remove. Okay, the step number one is quite important because you need to remove the IP address of the physical interface. Okay, then you can create a sub interface. Okay, so remember to remove any IP address by doing a no IP address command. Configure encapsulation frame relay on the physical interface. Create a sub interface using the dot, and then configure the IP address for the interface and set the bandwidth. And then configure the DNCI number. Okay, let's look at the example. Okay, step number one for R1, remove the IP address, and then say encapsulation frame relay. Okay, then create the sub interface using a dot and the sub interface number. So a number, you can use any number. So in this case, I use the number 102. Okay, because it's easier because I know the DNC number is 102, so I just use the sub interface 102. Okay, so I say that I want to use a point-to-point. This will be a point-to-point sub interface. Okay, then I set the IP address, the bandwidth, and this sub interface corresponds to DNC number 102. Okay, which is your connection to R2. My connection to R3 is defined by DNC number 103. So this is a command that I type. Okay, so again, create a sub interface 103, set the IP address, subnet mask, set the bandwidth, and finally set the DNC number for this sub interface. So this DNC number will connect to R3.